In this example, we asked to differentiate the following expressions in respect to x. So first we'll start with part A, where we have dy over dx is e to the power of 6x. So for us to find, so this is the expression, which is actually y, and we need to find dy over dx. So for us to find dy over dx, that will be taking the power, the number from the power, which is 6, and that will be 6 e to the power 6x, and that will be the differentiation for part A. For part B, we have y is e to the power of minus third x, and we need to find dy over dx, which will be, in this scenario, minus a third e to the power of minus a third x, and this will be our answer for part B. For part C, we have y is 7 e to the power of 2x. So for us to find dy over dx, that would give us 7 multiplied by 2 e to the power of 2x, which is 14 e to the power of 2x. For part D, we have y equal 5 e to the power of 0.4x. So for us to find dy over dx, it will be 5 multiplied by 0.4 e to the power of 0.4x, which will give us, in this scenario, 0.5 by 0.4, that will be 2 e to the power of 0.4x. For part E, we have y is e to the power of 3x plus 2 e to the power of 3 e to the power of x. So for us to find dy over dx, that would be, in this scenario, 3 e to the power of 3x plus 2 e to the power of x. So it will remain as it is, and this will be our answer for part E. For part F, we have e to the power of x, between brackets e to the power x plus 1. So first we expand the bracket. So first we will expand the bracket. So we just need to rewrite this. So e to the power of x, e to the power of x plus 1. So to find dy over dx, now first we need to rewrite y. So that will be e to the power of 2x plus e to the power of x. So to find dy over dx, that will be 2e to the power of 2x plus e to the power of x, and that will be our answer for part F. In this question, we need to find the gradient of the curve for the equation y equal e 3 to the power of x, and at x being, in this scenario, that various values. So first we look at a, so we have y equal e to the power of 3x. So first we need to find dy over dx. So for us to find dy over dx, that will give us dy over dx equal 3 e to the power of 3x. So now we sub add to dy over dx. So now we just need to sub x equal 2, so that's dy over dx equal 3 e to the power of 3 multiplied by 2. So that will give us 3 e to the power of 6, and this will be our answer for part A. For part B, we need to sub when x sub x equal 0, and we know dy over dx is equivalent to 3e 3x, and that will be 3e 3 to the 0, so that will be 3e to the 0, and that will give us 3, which will be our answer for part B. For part C, sub x equal minus 0.5, we know dy over dx is equivalent to 3e to 3x, so we have 3e 3 multiplied by minus 0.5, so that will give us 3e to the power of minus 1.5, and this will be our answer for part C. In this example, the function of f is defined as f of x equal e to the power 0.2x, and show that the tangent to the curve at the point f5 and e goes through the origin. So first we have the function of x being e to the power 0.2x. So for us to find the derivative, which is f of x, that will be 0.2 e to the power of 0.2x. So in this scenario, we have the tangent, the gradient of the tangent where x is equal to 5 is f of x, f of 5 at 0.2 e to the power of 0.2 multiplied by 5, which will give us 0.2, and this will be 1, so that will be 0.2 e. Now f of a, so now in this scenario f of 5 will also be in this scenario f of 5 will be e to the power 0.x, so that means f of 5 will be e to the power 0.2 by 5, which is equivalent to e. The equation of the tangent in the form y equal mx plus c. So this is the equation of the line. Now in this scenario we have the y coordinates, so we know the coordinates 5 and e, so this represents the x and this represents the y. So now we have the y is being e, and we have the tangent, the gradient is being 0.2 e multiplied by the x, which is 5 plus c. So now we can solve for c, so that will give us e equal e plus c, so that will give us c being equivalent to 0. Now therefore the tangent to the curve at the point 5 and e is in the form y equal mx, because the c is 0, therefore thus it goes in, so goes through the origin, and this will be our answer for explaining that the tangent to the curve at point 5 and e is in the form y, in the form of ymx, because we found the value of c to be 0, and thus it goes through the origin. And this will be our explanation for this question.